Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Uranus's largest moon, Titania. So, what do we see here? Well, here we see the largest of the moons of the planet Uranus. Now, this was explored back in 1986 by the Voyager 2 spacecraft, which is the only craft so far that has ever flown out to visit the two outermost planets, Uranus and Neptune. So we don't have any better images of it, only the images that were taken during that flyby. Now, 40 years ago, that occurred. Now, we see when we look at this that the structure looks in some ways similar to our own moon in that we see a lot of craters, but also some very different structures with a lot of cliffs and canyons and a lot more going on here than you might expect from something that is significantly smaller than our own moon. Our moon doesn't look very active. It hasn't been active for many billions of years. But Titania looks like it has had some kinds of activity even on a smaller moon. Now, how might that happen? Well, we have to remember when we get to the outer solar system and we look at things like this, while it may look like our moon and our minds may try to tell us, oh, look at the rock here, that what we're looking at is not rock at all. This is all ice. And in fact, a lot of it is water ice. Typically ices of water, methane and ammonia are common, sometimes carbon dioxide also present there, and other types of icy materials that are frozen out in the depths of the solar system. So when we look at something like this, we're not looking at rock, we are looking at ice. And we might imagine if it was heated inside, water can expand. So as water froze and expanded, then you could also get some of the fracturing from that. So that might be part of what affected the surface of this moon, as well as Ariel, one of the other moons of Uranus that shows something similar to this. So it is important when we look at the outer solar system, and especially the moons in the outer solar system, which are the solid bodies that we see, that we look at the geology of ice rather than the geology of rock, which is what we're used to studying here on Earth. Earth, we have rock that melts and gives us volcanoes and earthquakes, but it's very possible and likely in the outer solar system that ice behaves the same way, and that under the temperatures and pressures here, ice behaves in this area much like rock appears here on Earth. Now, of course, to study this more and to see the rest of this moon is going to have to wait until someday we decide to send another craft to the outer solar system to explore either Uranus or Neptune and try to look at them in more detail. They have only been studied, again, that one time when the craft Voyager 2 was able to travel out to the outer solar system during its grand tour of the solar system back in the 1970s. And that was because of how the planets were lined up on one side of the sun, that one craft was able to travel and use gravity assist to go from Jupiter to Saturn to Uranus and finally to Neptune. So that was our picture of the day, titled Uranus's largest moon, Titania. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.